Hey everyone, just Riley and I here thinking about science. I guess he's not thinking about science anymore. When we left off, we learned that sound travels through solids, liquids, and gases, and it was kind of our job to determine which one they travel better through. Now, we learned that sound doesn't travel quite as well through air as it does through other mediums. So I shared my story with being at the beach, seeing the girl digging, but not being able to hear her digging until I put my ear to the ground. So we haven't really gotten to investigate sounds through liquids, but we do have some idea that sounds travel better through solids than they do through gases. So we will investigate that further once we get back to school. I do have a short video that proves that sounds do travel better through solids than they do. And this video will actually give proof of how fast sound can travel through a gas versus a solid. So I would like you to watch the video, and then I'm going to show you a little experiment that you can do at home to try and just prove to you more that sounds do travel better and faster through solids than they do through a gas. And then tomorrow we'll dig deeper into investigating solids through liquids using a stethoscope and a tub of water. So look forward to that tomorrow. And then we also need to determine how long we can hear the sound through the tube versus the air, because we forgot to do that, or we didn't get a chance to do that on Friday. All right, watch the video, check it out. Check how sound travels through air, how much quicker sound travels through a solid versus air, and then I'll show you the brief experiment that you can do at home today.
If you don't believe that air vibrates, take a look at this. Sound waves can travel through solid things like wood as well. The particles in a solid are packed together far more tightly than air particles. What difference do you think this makes to the sounds you hear? Listening with a stethoscope can hurt. Does sound travel faster in the ground or through the air? And is the speed of sound ever as fast as the speed of light? To find out, you need to make a sound that can travel a long distance. 5 tons of plastic explosive should do the trick. How would you detect sound waves in the ground? Samantha's going to watch for the explosion, but she's wearing headphones so she can't hear it. Fung is going to listen for it, so he's wearing a blindfold. And Elizabeth's going to detect sound waves in the ground.
Ready?
Ready?
Ready.
So, who's going to be the first, second and third to detect the explosion? They were waiting to see the light, hear the sound, or feel the sound. Samantha was first because the light got to them before the sound. Elizabeth was next when she felt the sound coming through the ground. And Fung was last when he heard the sound of the explosion coming through the air. The speed of sound in the air is 350 meters per second. At 5,000 meters per second, sound travels much faster through the ground. But light is much faster than any sound, at 300 million meters per second.
So this experiment really works best if you have another body to help you out, but it basically just shows you how much better you can hear a sound through a solid than through the air. So what I want you to do is, and if you can have another person help you, like a brother or sister, mom or dad, grandma or grandpa, whoever you're hanging out with today, what you should do is you should have that person scratch the countertop, and then, or a table or whatever you have, and then you can listen to the sound through the air. And then what would work best is if you would find a spot kind of far away from where they're scratching. So if they were scratching down there, you would maybe listen over on this side of the countertop, and then you could hear the sound through the air, and then put your ear to the countertop and listen to the sound through the solid. And you should be able to hear the sound a little better through the solid versus through the air. So it all has to do with the molecules and how much faster they can travel through the solid, like you saw in the video, versus through the air. So that's kind of the little experiment you can do. Like I said, it works best if you can find another person to help you with it. And the farther away you are from the scratching, the better idea you'll get of how sounds travel through solids better than they do through a gas. And then we'll investigate solids through liquids tomorrow. So try that little experiment out. We'll share what you learned, and then get going on the rest of our investigation so that we can wrap it up and start working on Alaskan animal adaptations. All right, enjoy your snow day. Today it's just science and reading, and then if you need a little something extra to do, which I know you all do, you can read a little bit extra from your AR book. We'll see you tomorrow. Enjoy your snow day. Bye.